Hi everyone, I'm Asad Beg. I'm a technical account manager at AWS and I'm based out of Bangalore, India. Welcome to AWS Supports You, where AWS support experts provide tips to optimize performance in the cloud, lower costs, and provide you with the best practices and design considerations. Joining me today is Anirban and Gaurav from AWS Support. Can you give us a quick introduction, Anirban and Gaurav?
Thanks, Asad. Hey, this is Gaurav. I am a technical account manager based out of Delhi, India. And in my role, I'm assigned with strategic ISVs. I enable customers with migration support, cost optimization, and security reviews. I have interests in security and databases with focus on Amazon Aurora and PostgreSQL and MySQL. I'll hand it over to Anirban.
Hello, everyone. My name is Anirban Sina. I'm a senior technical account manager in Amazon Web Service. I work with large ISV customers, helping them to build and operate scalable and high-performance SaaS application in the cloud. I'm passionate about building scalable data, warehouse, and data solution for customers. Over to you, Asad.
Thanks, Gaurav and Anirban. So today we will be talking about implementing SaaS workload optimization with PostgreSQL. We will specifically focus on the Amazon RDS and Amazon Aurora Postgres of the AWS services. Now, before we get into the details, a quick note to all the attendees online. Please use the chat window on the right-hand side of your screen to let us know where you're joining us from today, and do share your thoughts and questions throughout the episode. We look forward to hearing from you. We also provide a link to our survey. So if you'd like to share how we did, then please click on the link and leave your feedback. So Gaurav, can you walk us through what we are going to be discussing today?
Absolutely. Thanks, Asad. So we have a packed agenda starting with introductions to RDS and Aurora. From there, we go into the multi-tenant deployment models and talk about data partitioning with RDS, also going into the tenant isolation strategies using Amazon RDS. We'll finally close it all off with a demo. Throughout the discussion today, we'll share links and resources with you via the chat. We look forward to your questions and shall try our best to take them on air. Please keep them coming. So with that, I'll get started. We begin with a customer story. An ISV or an independent software vendor typically serves multiple customers. In doing so, they have a requirement to use a tenant-based approach for their SaaS workloads. However, they would still want to keep a few things in mind. Agility plays a pivotal role as it determines the time to market. So that's on top of their priority list. ISVs are also conscious of the effort needed to refactor the code. They would also like the final solution to be secure because security is the center of everything that they do. And finally, keeping the cost down per tenant is also something that our ISVs are very interested in. So in this particular example, for this last ISV based out of Chennai, the TAM on the account worked with the customer architects to first deep dive into their current design and talk about their forward-looking plans. After due deliberations, they suggested using the bridge mode for their SaaS workloads. This was a happy middle path for them while the teams worked on refactoring the code to eventually move into a pool model. We'll definitely deep dive into the bridge and the pool models in the coming slides. So please stay tuned. Before we move any further, I would like to get us started with introductions to what is Amazon RDS and Amazon Aurora. Amazon Relational Database Service was built by AWS to help the customers reduce the complexity in supporting critical transactional applications. RDS is available on several database instance types, and they are optimized for memory, performance, or I/O depending on our customers' needs. We provide you with 6 familiar database engines to choose from, starting from Amazon Aurora, which is compatible with MySQL and MySQL, PostgreSQL, MariaDB, SQL Server, and Oracle. RDS has made it easy to set up, operate, and scale a relational database in the cloud. It also helps you automate the time-consuming administration tasks such as hardware provisioning, database setups, patching, and backups. HA is just one click away. So if you're looking to get going, RDS is the way to go. It also provides cost efficiency and is very easy to resize your setup once it's done. So what do we give you when we talk about RDS, right? We give you the ability to spend time innovating and building your apps and not spend time managing your infrastructure. While you focus on schema design, query construction, and query optimization, we take care of the automated failovers, the backups, the high availability, the security and compliance needs that you and your organization has in the cloud. Now, looking at Amazon Aurora took it a step further. Amazon Aurora is a MySQL and PostgreSQL compatible relational database built for cloud with the performance and availability of a commercial database at 1/10 the cost. With the separation of storage and compute, operations like backup are done without using your compute. The performance, hence, is built in. It is scalable. You can have up to 15 low latency read replicas. And especially using Amazon Global Database, which supports multi-region read replication, you can maintain low latency setup copies across not just AZs but regions. All your backups are stored on S3, and you also have the option of fast backtracking using the point-in-time restore. Amazon Aurora also currently builds its storage volume in 10 GB logical blocks called protection groups. The data in each protection group is replicated across the 6 different storage nodes. Our customers can get up to 128 terabyte worth of disk space for your mission critical databases. So with this summary, before we move on, I would like to have a quick check with our moderator, Asad, if there are any questions as we proceed on.
Nothing yet, Gaurav. So maybe we can continue.
Okay, thanks, Asad. So just doing a double click on the architecture of Amazon Aurora, right? So here I am showing you the graphical view of how the storage blocks are placed in different availability zones, right? These storage blocks get replicated in the backend asynchronously, and we wait for 4/6 write quorum and 3/6 read quorum to give you the satisfaction and the consistency that's needed in a commercial database. So from here, I would like my colleague Anirban to take over to take us further.
Hello. Yes. So in this section, thanks, Gaurav. So in this section, we are going to talk about various isolation strategies that can be applied when designing a multi-tenant SaaS application. So when you talk about SaaS generally, we talk about two halves. One is application plane, where your core business function works, like you implement multi-tenant web application, microservices, data partitioning, and tenant isolation. Other hub is actually a control plane, where it's mostly a horizontal services that encompass your application to operate and manage your application as a SaaS solution. Now, when you newly onboard a tenant and connect an identity to tenant context, we talk about control plane. We talk about a control plane where you are collecting metrics and analytics for your tenant. It also connects when you connect your tenant and your billing and metering story, that is also a part of control plane. So it's really about a shared services that you put around your application that lets you to position your solution as a SaaS solution. Now, in that application plane, you can put all kinds of different systems, right? But as long as you are putting all these blue boxes, horizontal services to manage and operate your application, then it becomes a SaaS solution. So in the next, let's walk through what are the core architecture concept when you talk about a SaaS, right? We are talking how we can physically and logically storing the data for one tenant from another tenant. That is called data partitioning, right? When we actually referring data partitioning, we are referring that it is not the same as a tenant isolation. So tenant isolation, where we ensure that one tenant cannot access another tenant's resources. So no matter what, if you're using IAM or any other security construct, you must ensure that one tenant cannot get to another tenant resources. We'll talk about SaaS identity. So SaaS identity is a basically where you are connecting your user identity to a tenant context. Now, and also it is important how this tenant context is flow through your system, right? Onboarding is another concept where your tenant gets introduced to the system and how that experience is going to look like. In case of tiering, where we talk about mostly what type of like basic tiering or advanced tiering. So in that case, how you offer your feature to your different tenants, right? And then then metering and billing system is just to measure the tenant consumptions and the activity in your system and generate bill accordingly. One of the key requirement to address SaaS is how you do isolate the data as well as the compute resources. So there are some key driver for that isolation strategy. Tiering is like basic, gold, and premium feature, which you will offer and has a different SLA requirement for your tenant, and that drives your different isolation strategy. It can be also a noisy neighbor scenario or your compliance requirement where you are forced to use no shared infrastructure. Or it could be a legacy architecture that impeding you to get into the multi-tenant environment. Your isolation strategy could be driven by your new opportunity like large enterprise or SMB market that you are trying to cater. Now, tenant isolation is one of the foundational topic for every SaaS provider that must be addressed. Crossing the boundary of any form would represent a significant unrecoverable event for a SaaS business. The domain, compliance, deployment model, or selection of different AWS services all brings its own unique set of consideration when you are actually creating a tenant isolation story. So there are some common models you find us talking about. We have mainly three architectural approach. On the left hand side, you have a silo where nothing is shared, but this will be operationally and cost wise inefficient. On the right hand side, you have pool model where it is a most common multi-tenancy multi-tenancy architecture which generally SaaS all the SaaS application followed, where infrastructure is been shared and that brings in a lot of optimization or operational efficiency, but achieving it would require an implementation of appropriate tenant isolation strategy. In the middle, you have a bridge model, in which case in certain of the layers of architecture are shared, others are not. Now, before I move on to the next section, I would I'll take a pause and see if there are any question so far.
Yes, Anirban. So, do we have one? We have one question from the audience member. The question is that these isolation models that you just spoke about, are they exclusively running to Postgres on RDS? Is what the question is.
Okay, so no. So these are the architectural concept. You can fit your any AWS services you are using into those architectural concepts. It is overall the way you are handling the tenant isolation. So that we are going to talk about those things in the following sections. Even the demo will give you an idea how can you actually separate those things out, right?
Okay. Yeah, thanks. And I think we also have a question from the previous section to Gaurav.
Mhm.
Gaurav, so the question is, what if I launch a single AZ or a single instance Aurora, right? Do I still get the benefit of the shared storage across AZs?
Yes, that's a very good question. Thanks for asking. And yes, you would. The replication is not. It's done behind the scenes for you to give you the needed reliability and high availability while using Aurora. So it is available. Yes.
Okay, thank you. So I think even if we go with a single Aurora instance for my cluster, my storage would still be spun across multiple AZs, thereby making it more durable, right?
Exactly.
Okay.
Yes, that's how it's designed to give you the most resiliency and high availability while using Aurora.
Perfect. Thanks, Gaurav and Anirban. And Anirban, I think we can continue.
Thank you. Okay. So moving on, in this section, I'm going to talk about attribute-based access control and how IAM and attribute-based access control can be leveraged to achieve data partitioning in RDS PostgreSQL. So the fundamental goal of our tenant isolation is to ensure one tenant is prevented from accessing the data and resources of another tenant. Now, let's dive deep how IAM and tenant isolation works together. Now, there are three main tenant isolation method in IAM. Let's briefly review them one by one. So, one is role-based access control, where each tenant has a dedicated IAM role or a static set of IAM role uses to access the tenant resources. The number of roles in ABAC equals to the number of the role definition multiplied by the number of tenants. So RBAC works well when you have a very small number of tenant and relatively static policies. Dynamically generate IAM policy is the method where you dynamically generate IAM policy for a tenant according to the user identity. You may use this method when you have a highly dynamic environment where roles definition frequently change or added. You may also choose this if you prefer to generate or manage IAM policy by using your code. Finally, attribute-based access control, ABAC. In this method, it is suitable for a wide range of SaaS application because it lets you rely on the native construct of IAM for policy management. You may choose ABAC if your use case doesn't require to support for a frequently change or added role definition. Now, in case of attributes, attributes are known as a custom tag in AWS. It is used for cost allocation, discovery, access control. In ABAC, instead of multiple role and permission set for different resources, you are going to have one rule-based permission. On the left, identities has attributes and you set those attributes to the identities. On the right, you have resources and resources also can be set a different tag or attributes. In the middle, you have a very simple rule that is based on matching. So you can write a very powerful, simple generic rule that allow you to match a custom tags. In our demo today, we are going to show you that how you can tag a role and a resources, and you kind of start seeing that the how SaaS application can scale with thousands of tenants, because now your job is not to update the policy, rather your job is to make sure that attributes are set properly for your tenant and resources, and then the permission will take care of themselves. So let's explore how you apply a data partitioning concept in the SaaS application. If you look at RDS, in the silo model, we could be separate database instances or cluster per tenant with a complete separate set of table for each tenant. The silo model excels in case of when you need a tenant performance and security isolation. It also completely eliminates noisy neighbor phenomena. On the other hand, we can implement a pool model by provisioning a single Postgres instances and then use a row level security to maintain the tenant data isolation. Row level security policies restrict which rows in the table are returned by a select queries. So this is where the isolation become a little difficult because your database tables are now shared by multiple tenants and there should be a fine-grained access control to protect a tenant resources. So unlike silo example, resource-based access cannot be used to achieve tenant isolation. Instead, a single Postgres instance must be able to process the request from all the tenants and isolate specific to the tenant or items based on their context. Now, when we talk about silo isolation, we focus first on the resource-based isolation, right? In this case, our isolation model is on one where the tenant is essentially isolated in a single resources, like a single database instances, a single compute node. And here, the isolation boundary is actually a entire resources. And it is much easier to build because your isolation model usually construct like IAM policies, roles that works on the resource level and can restrict your access at this level. But when we have a pool isolation level and that environment, in the pool environment, it has to be an item level isolation. So here we need a more fine-grained view of the isolation because now your tenant information is actually shared within a resource as an individual item. So in this example, I have a database table where you can see an individual item are associated with multiple tenants. Now, this could be an RDS or any databases where you store the data. The idea is that we are now moving inside the resources, and now individual item inside the resources are the things we need to isolate. Now, this is where the isolation gets a little tricky. We have to define a security policy on the table, and this policy should restrict the rows in that table that are returned via select queries or that is affected by insert, update, or delete commands. Now, this enforcement of RDBMS low-level isolation policy at the table is complex, and it is also a burden of your software developer. Now, in the silo environment, when you are isolating a resource level, we can rely on the time of deployment. So when you are deploying the resources, you create an IAM role, attach it to the resource, and then the isolation level is done. But when you're talking about item level isolation in the pool model, we can't really on the time do it in the deployment time. We have to have some way to do it in a runtime, or we called as we called it as a runtime applied or runtime enforced isolation. So at the runtime, when tenant comes in, they try to access some resources. They all will be coming as an environment in the same resources. So in the pool resources at the runtime, our code actually has to go out and say that, oh, you have this tenant context, or you are coming from coming as an tenant 3. Let me go and grab what tenant 3 can do by grabbing it up tenant 3 policies, and then apply the policy and the runtime to scope down the access. Now your resource, when resource is deployed, it had to be deployed in a very wider context to support all the tenant can come in. Now at the runtime, we have to resolve the tenant called, find out which tenant it is coming, apply the policy dynamically based on the incoming tenant context, and then this will be co-scoped to your access. Now this context gets applied when you are using attribute-based access control. So our code sends a request to the database authorization and gets the credentials back and access the piece of data it is supposed to access or it is allowed to access, and that's the way how we scope our access. So here in the runtime enforcement and isolation is really comes in the scenario where you are doing item level isolation. So let's review a sample ABAC policy with a session tag, how ABAC can help you to do the isolation, tenant isolation in an item level. So this is a sample policy where operations and actions are allowed when the user resource tag and principal tag have the same value for the tenant key. Now, once you have this permission, you go and create a resource. You can modify the resources. You can tag it the way you want, but you don't have to touch the policy when the new tenant comes in, because it will be applied in the runtime. So this gives a lot of flexibility to the administrator and lot of freedom for developer to go ahead and do the development. Now, before I hand over to Gaurav, I would I would take a I will take a pause and ask Asad if there is any question.
Yes, Anirban. So there is a question, and also, I had a couple of queries myself. So, firstly, let me pick up the question from the audience. So, one of the members is looking to understand if the row level security is supported both in RDS Postgres as well as Aurora Postgres.
Yes, it is supported in the both RDS Postgres and Aurora Postgres.
Okay, thank you. And based on what we were highlighting so far, right? Is it possible, let's say, to break out a tenant and then read the data?
Yes. So when you're talking about the tenant, you have to we talked about SaaS identity. So you have to put your user identity with a tenant context, which become a SaaS identity. When you have a SaaS identity and close it to the system, in the
Mhm.
system you can actually separate the tenant data either within a single table, or you can actually separate with the database different schemas and creating a separate table.
Okay. Thank you. And one additional thing is, how can I be, let's say, 100% sure that my tenant data is completely isolated?
Okay, so there's in the demo, I will show you that when you actually create a role, you don't give in the first time when you are creating a policy, you are not giving anything, and that at runtime you are setting the context by sending a tag key. Based on that key, the scope has been defined. So it is more likely when one role is assuming another role to get an access of the data from a database, that particular time and the runtime applied context is very limited, right? It is it has to be like, once you set it correctly by your application, it is ensure that your IAM construct itself will create a STS token, and then scoped it, and like ensure that the tenant isolation is been done on that level.
Okay, then I'll probably wait for the demo then.
Yeah, sure.
Yeah. Thanks, Anirban. No more questions at the moment, so maybe we can let Gaurav proceed.
All right. Yeah. Thanks, Anirban and Asad. So, as Anirban was taking us through the different isolations, I think that's a good point for us to talk about a high level architecture. Let's start with a very simple three-tier web application architecture in which the static content is handled via CloudFront through S3, and the dynamic requests flow into the API gateway post processing of the business logic. And finally, makes it to the data store at the backend, right? So this is the basic structure of the application that we are going to start with. Now, in this example, we have also included two simple e-commerce microservices, product and order, that provide basic CRUD operations, which is create, read, update, and delete. And each of these services use Amazon RDS to store and manage their data. So overall, this architecture includes the fundamental elements that are part of a basic serverless web application. Now, as we move forward and talk about the different models and the modes, we'll introduce the IAM policies and tenant context that will be used to ensure the tenants are only allowed to access their own resources and not the resources that are not supposed to be under their purview. So let's get started. So I'll just quickly change to a different view. So looking at the tenant isolation using PostgreSQL, focusing on the silo model, right? So in this silo model, the implementation is done by provisioning a PostgreSQL instance for each tenant in an application. Now, because of this structure, this model excels at tenant performance, security isolation, and it completely eliminates any noisy neighbor phenomenon that you may otherwise encounter, right? Here we are using a separate API gateway for each tenant. However, there is also an approach in which the tenants can potentially share an API gateway, and the API gateway then routes the traffic to a tenant-specific business function, and then it eventually goes into the database. Um, so in this setup, of course, there is some duplication. All the Lambda functions have the same code, and they have similar structure in terms of database, because that's your application schema that you want. But it's duplicated. And then each endpoint is defined in an environment variable of Lambda, so that a separate role for each Lambda function can be used, permitting it to only access that endpoint. And eventually, as roles work, right, they have an IAM policy that grants them permission only to a specific tenant on the instance. So in case of any cross-tenant connect, a call would be denied by at the IAM level itself, because it won't match the endpoint resource name as specified in the policy. So I would say the key takeaway of this silo model is that Lambda functions, the endpoints and roles, each map one-to-one at the individual tenant level. Now, moving from here to the next one, which is the pool model. The pool model is implemented by provisioning one single PostgreSQL instance. It could be, again, Amazon RDS or Aurora, as Anirban explained. Both of those support it. And then using the row level security, we can maintain the tenant data isolation. Now, these RLS or row level security policies restrict which rows in a table are returned by select, insert, update, and delete commands, right? So this is where isolation is a little tricky, especially if you're trying to do it statically. And therefore, we recommend that you use a finer grained IAM policies to protect your resources. And because unlike the silo model example, right, the execution role cannot be constrained to a specific tenant. It must be able to process requests from all tenants, but it should still be able to only read the data that's tied to a particular tenant. Now, as each request would come in this model to the Lambda function, we will apply a policy at runtime or dynamically based on the incoming tenant's context, right? So this context gets applied using something called attribute-based access control, or ABAC. So attribute-based access control allows you to parameterize your policy to precisely define the authorization that's needed. And again, IAM then validates the request, returns the database password as a token, as a one-time token, and then Lambda can use that to call the Aurora Postgres compatible database or the Postgre RDS, right? And this is where Anirban will take us through in the demo, and then go into a little more detail on how this is working. And we use tags here. So tenant ID tags are used to clearly define and enunciate that. The access, once granted, basis of the tag has to, of course, the tag has to match the resource name, narrowing the data to just those rows, and then the data operations are allowed. Okay, so this is how the this pool model works. And now, looking at the bridge mode, right? So this represents actually a combination of the silo and pool models. So here, not all, but some of the layers at the infrastructure level are shared, while others are dedicated to each tenant. So there are advantages of using silo and pool, and then this is a happy middle path, which has its own advantages as well. So in our bridge approach, the API and Lambda function are shared, but the PostgreSQL instance is provisioned at the tenant level. And to maintain tenant data isolation, you use the logical constructs within the database schema, and logically separate the data. Now, the entry point to this solution looks very similar to what the pool model is, right? It again uses ABAC and fine-grained flexibility of dynamic policies to control any access to the tenant data. This approach also requires that database connectivity from all the Lambda function is allowed, and then shared Lambda execution role can be used to achieve that. So in this design, the Lambda function takes the tenant name from the context, passed as a custom clean Java or web token or JWT. And then we use the tenant identifier as a database name to access the specific tenant data. So like I said, it strikes a balance between the two models that we looked at prior. So understanding and listening into all this, I am sure there are questions, right? How do you really go about choosing your data model isolation strategy? In this table, I'm trying to highlight some of those, and there is no one answer that works for every one of us, right? There are advantages and benefits of using all three models, and then it's really where you are in the journey of putting your SaaS tenants out there is where the answer would come from. So to highlight and quickly look at a few points, right? The silo model, the clear benefits are that you don't have the noisy neighbor interference, so you don't have to really work on it and address it at your code level. You can get the tenant level cost metering. You don't have to bring IAM into your code base. Disadvantages, of course, cost is a big challenge as compared to the other two models, and it also reduces your time to market. So which is the most pressing concerns that we have seen our customers have, right? Um, but if you want maximum isolation and minimum latency, this is your model, and then silo is the preferred approach. Looking at pool model, it provides better economies of scale. It reduces the risk of hitting any quotas that you may otherwise hit, and the provisioning times become shorter with this. It would still require some code changes, and then there is a medium to complex management overhead that comes with it, and there are data access latency penalties. However low they might be, they are still there. So if you have a very low latency workload which cannot take even a millisecond worth of lag, then this model may not work well for you. And when to use it, when you use the when you want the cost to be low, and your tenants are ready to be onboarded, and their usage pattern is not as frequent, right? So this is the model that can be used there. Bridge model. So this, like I said, has a happy balance between the other two models, right? So if you have to cross-reference any data across tenants, then definitely this is one model that is very useful. The any extensions that you're using as part of your database, that effort becomes one time with this model, because you are end of the day using a common setup. The overall disadvantage, if I am to call out, is the new tenant onboarding agility is moderate, not as agile as say the other models, and complex database maintenance tasks would have to be undertaken because your system catalog tables will grow proportionately, right? When to use it, when you need a balance, and the time to refactor the code and the effort going in is there, and then you want to make sure that you have a strategy to achieve that. So at this stage, I think we are all set for the demo. However, before I bring Anirban to take us through the demo, I would like to ask our moderator Asad if there are any questions from the audience at this stage.
No, Gaurav, no questions. I think the slide, especially that we are at which we are right now, the benefits, disadvantages, and when to use. I think that perfectly sums it up. I believe we can straight away proceed to the demo.
Sure. Yeah.
Okay. Sure.
Over to you, Anirban.
Yes. So let's bring up the demo. Okay. So today we are like in this demo, we are going to talk about the pool isolation model for Postgres. So what we are doing here is that we'll be running a Python notebook with an execution role that will not have an access to run any type of connect to the databases, okay, in the Postgres. We'll have another role which will have a parameterized policy where we'll set up the session tag, assume that role, create an STS token, send that token to create a authentication DB request, and then we'll get a password token, which will be only be used for 15 minutes. And then with that token, we'll go and access the DB endpoints. Now, in this scenario, so if you see, so that token is just for 50. It will be enabled only for 15 minutes. Now, the first thing what we'll do, we'll go and create the database. Okay. So in this scenario, so in this case, we'll go and create the database, and then while creating the database, we will, once it is done and available, we'll take a note of few key points. One is, what is the endpoint? What is the certificate authority? And in the configurations tab, we are also going to took a note of what is the DB name, and we want to make sure that IAM DB authentication is enabled, because we'll be accessing this database through our IAM policies, IAM roles. Now in the database, we logged it as an administrator, create two user. One is IAM1 and IAM2. We'll give also a RDS underscore IAM grants to that user. While doing so, we'll also create a database, and we'll give that database all privileges access to IAM1 user and IAM2 user. Once we have done that, we'll log into the newly created database. So let's log into that newly created database. Once you log into the database, you give a select privilege of all table within the database to the IAM1 user and IAM2 users. We're going to create a table where the tenant ID will be one column and product ID and SKU will be other column, and then insert 3 rows. One is for IAM users and 2 are for IAM2 users with product ID and SKU. So once you've done that, we'll run that query with the administrative privileges. So if you have a now administration privilege, you can see all the data. So now we can see the data. There is 1 record for IAM1 users and 2 record for IAM2 users. Now to enable the row level security for that particular product table, we'll alter the table and enable the row level security. And we'll create a tenant isolation policy on the product table that with a check that matches with the current user with the tenant ID in the column of a product table. So now let's create some roles, right? So we said that we have a notebook which runs in a wider execution role, which is an Amazon SageMaker execution role. Now this role is created a trusted relationship with this role, and this role will going to assume this particular policy. But while like assume this policy, it has to pass the principal tag that is identified as a tenant ID, and it has the access to connect the DB, where your original execution role doesn't have an access to that. So it has to assume this role to access the database. Now here we are creating a very using Python SDK. We are creating a temporary session where we are passing an role ARN and the tenant ID and setting up the tag over here. So your tenant ID has set up a tag. This is creates for the temporary session, right? Now when you pass that tag over there, the tag will be replaced over in this particular policy in the runtime, and this will be accessed via this execution role, which has an assume role and tag session privilege. Now let's run a product again by the administrator user, and we'll see that IAM1 and IAM2 has two rows, right? And IAM1 user has one single rows. Okay, now let's set the tenant ID as an IAM2 and create a temporary session. So once you run that tenant ID, run that, we are going to run and you give that temp row which has that ARN, which is ASY temporary demo role, which has that dynamic policy, ABAC policy, and then we'll call that to create a temporary STS token, a temporary session, and that with that session we'll call the DB authentication token, create a DB authentication token, which is just active for 15 minutes. Now this particular token is scoped only for tenant 2. So when you when you run a query on that particular table, on the product table within that database, though we are running a select star query, that means select tenant, product ID, and SKU from that for that particular product table, because it is scoped only for tenant 2, it will only bring up 2 records. It will not bring up the record which is a tenant ID set up as an IAM user 1. Now let's run the same code with the IAM1 users, create the same session, but it will create a new DB authentication token. Now this DB authentication token now which is created is scoped into for IAM1. And this concludes our demo. Thank you, everyone. So back to Ashad. Ashad, do you have any questions so far we can take?
I'm just checking. Well, I don't see any questions, Anirban. I think there was one question about the demo itself, which you shared right away, and it also summarizes what we did, what we discussed throughout the session today, especially about how do I make sure that 100% my data is being isolated or not.
Right.
So yeah, so that brings. Yeah, do you have?
Asad, sorry to interrupt. So yeah, there is another working code base that's checked into GitHub that our customers and viewers can also refer to.
Okay.
We'll put it in the comments section, so it gives a quick guide. They would just need to migrate to the CloudFormation template, and it will quickly launch the setup for them, and it can be used as a play around to test out the different modes that we have talked about.
Perfect.
Yeah, back to you.
Thanks, Gaurav, to bring that up. So everyone, today we looked at how to implement the SaaS workload optimization with PostgreSQL. We also looked into the multi-tenant deployment model, the data partitioning and tenant isolations, along with a demo. And if there are any questions that you still have, you can post your questions on the repost.aws, where one of our experts can provide you with an answer, or your question could become a topic of one of our future shows. So if you also have a feedback, please check the chat box on the right for a link to our survey, or you can email us at awssupportsyou@amazon.com. We want to hear from you. Tell us what else you'd like to see on this show. Please join in again in 2 weeks on February 22nd at 10 a.m. IST, where we will be discussing about reducing costs and improving performance with Amazon Document DB. Thank you for joining us at AWS Supports You. Happy cloud computing.
Happy cloud computing.
Happy cloud computing.